Tilek to everyone. Today I'm going to discuss only a small topic that is second order derivative. Okay, now in the previous class we had discussed about finding the derivative of various functions like implicit function, explicit function, inverse trigonometric functions, logarithmic function, exponential function, function in parametric form, right? So we have all these types of functions, and now you know how to differentiate all these functions, okay? Now today I'm going to show you how we can find the second order derivative of a function, right? So for doing this, I'm going to give you a small example, okay? So I'm going to take a small example where we apply second order derivative, and you're frequently using that in physics, okay? So first I will give you three terms here. Displacement, let me denote it by delta x, okay? Then we have velocity, which I denoted by small v, and we have acceleration, which I denoted by capital A, okay? Now you are familiar with these three terms, so you are frequently using these terms in physics, right? Okay, now if I say delta x, that is the displacement, if I differentiate displacement with respect to time, okay, so then what do I get? I get velocity. You remember that, right? So what do I have when I differentiate displacement with respect to time? I get velocity, okay? Further, if I differentiate velocity with respect to time, then I get acceleration, right? So this is the relation between these three terms, okay? So now I can say that velocity, how do I get velocity? That is differentiating displacement with respect to time, I get velocity, right? Further, when you differentiate velocity with respect to time, then you get acceleration, okay? So when you differentiate displacement with respect to velocity, you get, when you differentiate displacement with respect to time, you get velocity, right? Further, when you differentiate velocity with respect to time, then you get acceleration, right? In short, we can say that velocity is the first order derivative of, I can say this, velocity is the first order derivative of, first order derivative of displacement, right? Okay, so when you differentiate displacement once with respect to time, you get velocity, okay? Now instead this I can write it as, okay, so this term I can write, okay, v is equals to this, so I can write this divided by this, okay? So I can write, instead of velocity I can write velocity is the derivative of delta x with respect to time. I'm just replacing velocity in terms of delta x and time t, okay? So this is equals to acceleration, okay? So when you differentiate delta x, which is displacement, with respect to time 2 times, okay, so then you get acceleration. So in such case we call acceleration is the second order derivative of delta x, okay? So when you differentiate displacement with respect to time once, then you get velocity, okay? Further, when you differentiate it, which means you are differentiating displacement twice, okay, so then you get acceleration, okay? So we say that velocity is the first order derivative of displacement, and acceleration is the second order derivative of displacement. You are differentiating displacement 2 times. Is that clear? So this is one application of second order derivative where you can find out this, okay? So there are certain, this is one small example. So there are many other fields where we need to apply second order derivative, okay? So second order derivative means, now if I define it, so second order derivative means you are differentiating a function twice, okay? So first you will differentiate a function, and that derivative is to be again differentiated, so which is called as the second order derivative. So it's there is nothing new. you will be given a function, you have to differentiate that function twice, which gives us the second order derivative. Okay, when you differentiate a function once, we call it as first order derivative. Again, when you differentiate that, that is called as the second order derivative. Okay, so you can see with this example, you can clarify the concept of second order derivative. Okay, so when you differentiate a function once, that is called as the first order derivative. So when I differentiate velocity with respect to time once, we get velocity. So we say velocity is the first order derivative of displacement, right? Again, when you differentiate this velocity, which is you are differentiating displacement second time with respect to time, that is acceleration. So acceleration is called as the second order derivative of displacement. But in terms of velocity, acceleration is the first order derivative of velocity. You are differentiating velocity once. Is that clear? Acceleration is the second order derivative of displacement, but acceleration is the first order derivative of velocity. Now don't get confused between these two, right? When you differentiate displacement twice, then you get acceleration, but when you differentiate velocity once, then you get acceleration. Okay, so you can define acceleration in two terms, that is acceleration is the first order derivative of velocity, or you can say that acceleration is second order derivative of displacement. When you differentiate displacement twice, then you get acceleration. Also, when you differentiate velocity once, then you get also acceleration. Okay, so in both ways you can say. So now when we come to mathematics, we are dealing with only functions. Okay, so you will be given different types of functions. So however you are given any type of function, so when you differentiate that function once, which we were doing in all the previous exercises, okay, so these are called as the first order derivative, right? Further, when you differentiate that derivative again, so that is called as the second order derivative. Okay, so now we will take functions and see how we can find the second order derivative. Okay, first, before doing some examples, I'm going to denote how I will show you how we denote second order derivative. Okay, so our function is, this is a standard function which we were taking till now. Okay, so every time we write y as the dependent variable and we express y in terms of x. Okay, so when you first order derivative, okay, so you write dy by dx. When you differentiate y with respect to x, so we write dy by dx. This is equals to, if your function is written in fx, then you can write f dash x. Okay, so dy by dx, f dash x. So these are the notations you use for first order derivative, is it? Similarly, in some books you may find y dash. Y dash is also notation for first order derivative. Okay, also y suffix 1. This is also, in some books, this notation may be used. Y suffix 1 means it is again dy by dx. Whether you write this or this, these two are same. All these four are same. Some books you may be written as curly y by curly x. So this is also a notation for derivative of y with respect to x. So all these are notations you used for first order derivative. Okay. So these are first order derivative. Okay, now in second order derivative we need to differentiate this, so we are differentiating dy by dx. Whatever we got here, that is to be differentiated again with respect to x. So derivative of dy by dx, so that is second order derivative. So this you can write it as, okay, d2, okay, y by dx. So that is dx square. It is written like this. Okay, so please be careful with this notation, because many times students make this mistake. They write dy square by dx square. So this is incorrect. Okay, so it is d2y by dx square. It is read as d2y by dx square. Okay, so this, either you can write this, or if you want to write it in this form, then you will write f double dash x. Okay, also if you want to write it in this form, you can write y double dash. Okay, this is, or if you want to write it in the form of suffix with y, so then you can write y2, right? Or if you want to use this notation, then you can write curly 2y by curly x square. Okay, so these are all notations you can use for second order derivative. Okay, so this is how we denote first order derivative and second order derivative. Okay, so in different books different notations are used, so don't get confused. Okay, so all these notations are being used for second order derivative and all these are used for first order derivative. So whichever you want you can use them. Okay. Okay, now we will consider a few examples. Now this is very simple topic, it's a small topic. Okay, and this is the second last topic of this chapter. Okay, if I write okay, find the second order derivative of y is equals to x square plus sine square x. Okay, find the second order derivative of y is equals to x square plus sine square x. Okay, so to find the second order derivative, first you need to find out first order derivative. So you can write dy by dx is equals to, okay, so now this is explicit function, term by term you can differentiate. So what is derivative of x squared? That is 2x, right? Okay, plus what, now we need to differentiate this, so that is sine x whole square. So you need to apply chain rule here. Okay, so sine x whole square means first you will differentiate as a whole, so that is 2 into sine x. Okay, then you need to differentiate sine x, which is cos x, is it? So you can write it like this. So if I apply one formula over here, then I have, you can use one identity over here, because later if you apply the identity here, differentiating will become easier. Okay, so therefore 2x. Okay, so this is 2 sine x cos x is sine 2x. Okay, now to find, this is your first order derivative. Now to find the second order derivative, you need to differentiate that again. So that is d2y by dx square. So this is equal, now again you have to differentiate this. So that is 2, derivative of 2x is 2, plus first you will differentiate this as a whole, it is a function of sine. So what is the derivative of sine? It is cos. So that is cos 2x. Okay, then you need to differentiate the angle. Okay, into what is the derivative of 2x? It is 2. Okay, so from these two I can take out 2 common. Okay, so what I'm left with here, I have left with 1, plus here I'm left with cos 2x. Okay, so this is your second order derivative. That's it. So this is how you have to find out. Okay, now only the concept of the second order derivative is new to you. Otherwise, how you differentiate earlier, it is same to be applied here also. Okay, so either you can use this notation or you can also write y dash. Okay, so this is y dash, this is y double dash. So we have y double dash is equals to this. Either you can write y double dash or you can write d2y by dx square. Any notations you can take. Okay, let it be the first example. If I take one more example, now you will try to do this by yourself. Okay, now we'll take this y is equals to square root of let me take, okay, 10x square. Okay, so this is equals to, now y dash is equals to, as a whole it is a function of root, so that is 1 upon 2 root x, so that is 10x square, into what is derivative of 10? It is sec square, so that is sec square x square. Okay, into, then we need to differentiate this, so that is equals to 2x, right? Okay, now we have completed this. So now we'll try to simplify this. I'll cancel out 2. Okay, so I have this x, I will write it first, x. On the numerator I have sec square x square whole divided by square root of 10x square. Okay, now to find out the second order derivative, we need to differentiate this. Okay, so for that we need to apply a quotient rule, because it's a fraction. Okay, also we need to apply a product rule when you are differentiating the numerator. Okay, so y double dash is equals to, first you have to differentiate the numerator, which is a product of two terms, right? This is first term, this is your second term. So derivative of x is 1. Okay, derivative of first term is 1, derivative of x is 1. Second term as it is, that is sec square x square, okay, plus, right, x as it is. Now you have to differentiate this, so that is derivative of first as a whole it is, so you will differentiate this as 2 sec x square. Then you need to differentiate sec, which is sec x 10x, right? Then you need to differentiate x square, that is 2x. Okay, that's quite lengthy, so you have to differentiate all the terms. Okay, so you close the bracket. Okay, then denominator as it is, that is root into root 10x square, plus numerator as it is x square x square. Now you need to differentiate this, so that is differentiate root 10x square. Okay, so you'll get the same over here because we had already differentiated this, so that will be x square whole divided by root 10x square, okay, whole divided by all this term divided by denominator square, that is 10x square. Is it okay? So now you take the like terms and try to simplify this term. Okay, so you will open the brackets and simplify this term and collect the like terms, which gives us y double dash, that is the second order derivative of y. Okay, so in short, when you are asked to find out the second order derivative, then what you have to do is, first you will find the first order derivative, that is dy by dx. Okay, then again dy by dx is to be differentiated with respect to x. Okay, that is the second order derivative of the given function. So this is how we find the second order derivative. Okay, now we will take this third example. It's slightly different. Okay, the way of asking the question is slightly different, but the concept is same. Okay, you are given this: if y is equals to 5 cos x minus 3 sin x, prove that y suffix 2. Now what do we mean by y suffix 2? It is the second order derivative of y. Okay, so I told you earlier, so different notations are used. Okay, so y suffix 2 or y double dash or f double dash x, all these are for second order derivative. Okay, so second order derivative of y plus y is equals to 0. You need to prove this. Okay, so every time whenever you are asked to prove something, some equation, then you look at the terms given in that equation. Okay, so try to obtain all these terms. Okay, so here we need y is already there, and now we need second order derivative. So first we will try to find out the second order derivative, and then we will substitute everything in this equation, and we'll see whether it satisfies this equation or not. This is how we are going to do. Okay, so here I have y is equals to 5 cos x minus 3 sin x. So first we need to find out first order derivative to find out the second order derivative. And since this notation is being used, I will use this y suffix 1, means it is the first order derivative of y. So this is equals to 5. What is derivative of cos x? It is negative sin x. Okay, minus 3. What is derivative of sin x? It is cos x. Okay, so I can write this as minus 5 sin x minus 3 cos x. Okay, now we have to differentiate this again to get the second order derivative. Okay, so this is minus 5. What is derivative of sin x? It is cos x. This negative 5 is the coefficient, so coefficient you keep it as it is, and then you differentiate the term. Okay, minus 3. Now you differentiate cos x, whose derivative is minus sin x. Okay, now this is equals to minus 5 cos x minus minus plus 3 sin x. Okay, so this is my second order derivative. Now I'll try to suppose it here. So I get y2 plus y1 is equals to this is minus 5 cos x plus 3 sin x. This is your y2. Okay, plus y1 not y1, sorry, it's y2 plus y2 plus y. This is your y, so that is 5 cos x minus 3 sine x. Okay, so now we'll try to solve this. Okay, negative 5 cos x plus 5 cos x. These two will get cancelled, right? Plus 3 sine x minus 3 sine x is equals to 0. So here this is equals to 0, hence proved. Okay, so this is how you have to do. Okay, so now the thing only you have to know is to find the second order derivative. First you will differentiate the given function once, from where you get the first order derivative, and then you will differentiate the first order derivative again with respect to x, okay, to obtain the second order derivative. Okay, so the question may be given in the given in two types. One, just you will be asked to find out the second order derivative, or else you will be given the function and you need to prove certain equations. Okay, so you just look at the equation which is to be proved, and in that equation see what terms you need. If in first order derivative, second order derivative, and then you substitute all these in the given equation and see whether it satisfies the equation or not. So this is how such questions are to be done. Is that clear? Okay, so I think this is a very small topic and you won't face any problem. Okay, because if you are clear with the concept of how functions are to be differentiated, then it is just a generalization of differentiation, because a function is to be differentiated twice and all the procedures or methods you are using is same. So to clarify the concept of second order derivative, you will do exercise 5.7. okay, so this is a small exercise, few questions are there, okay, where you have to find out the second order derivative. Okay, so today you will complete this exercise. So this is the second last topic of this chapter. Now we have one more topic to cover, which is a small topic, okay, and that I will complete in the next class. So till then you will take care of yourself and stay safe. Thank you.